Evaluate functions. Function notation. So function notation really means is that we have, say, a function, which can be represented as like a little f. It can be a big F. It could be a big G or a little g. But then what follows is that we have parentheses, and then we put something like an X in there. It could be a Y. It could be an R. It doesn't really matter. But what happens is that this represents the function. This represents a variable. And so what happens is what is inside of the function will replace the variable. So we can evaluate functions. So what this means is, let's look at an example. So let's look at example 1. So we have big F, which is like showing us as a function of R, which is equal to 4/3 pi r cubed. Now we have seen this, but this is something really familiar, right? We've done these things where we look at the radius and we say the radius is 2. Now we evaluate. So I just wanted to show we have done things like this. It's just a little different. But what happens is that now we're showing that this is a function of r. And so what we're saying is we're going to go ahead and replace the r with a 2. So anytime we see an r, we're going to replace it with a 2. So let's go ahead and rewrite this. So we have f of 2, which is equal to 4/3 pi r. Well, instead of r, we're going to put actually 2. And we're going to always put anything we insert into our function in parentheses. So we're just going to write through parentheses, and this is cubed. So now let's kind of go ahead and simplify this a little bit more. So we have 4/3 pi. Now we have 2 cubed. Well, 2 cubed is just 8. And so now we have it kind of more simplified, or we can go 4 times 8, which is 32/3 pi, which then becomes, let's go pull up our calculator. So you have 32 divided by 3 times pi, or we can go 3.14, and we get 33.49. So we're just going to round to the nearest hundredth. So when we evaluated the function, with r being 2, we get this answer. So really, what does this mean? So kind of like another way to think about it is, say we have a f of 2, which then goes into a function, right? And our function is 4/3 pi r cubed, right? That's our function, f of r. And what comes out is we get 33.49. Now we can change this number, right? The radius could be 8, for instance, or 10. And therefore this number is going to be different. But, so it's something kind of what we have seen. We're just making it a little bit fancier. So now let's look at another example. Example 2. F of x is equal to 4x squared minus 7. Find f evaluated at 3. So once again, we are just going to put this 3 into this variable. Anytime we see this variable x into the function. So our function is 4x squared minus 7. So let's go ahead and rewrite this. So we have f of 3, which is equal to 4, put in parentheses, 3 squared minus 7. Well, 3 squared is 9, so let's go ahead and rewrite that. Now, if I just do this equal sign, this means that this just gets carried down. Now we have 4 times 9, which is 36 minus 7, which is equal to 29. So when we evaluate this function, when x is 3, we get the answer of 29. Now let's look at one more example. Example 3. We have g of x, which is equal to x cubed plus x minus the square root of 2x plus 6. Find g evaluated as 5. So now we're putting 5 in for x. So let's go ahead and rewrite this. We had g of 5. Now we have 5 cubed plus 5 minus 2x plus 6. So we have 2 times 5 plus 6. So let's go ahead and start to simplify. 5 cubed is 5 times 5 times 5, which is 125. Then we have plus 5. Keep these all in parentheses. Minus, now the square root of 2 times 5 is 10 plus 6. Plus 5. Now we have 10 plus 6, which is 16. We take the square root of 16, which is equal to 4. So we're just going to go ahead and simplify more. So 125 plus 5 is 130 minus 4. So that would be 126 as our final answer.